Hi, my name is Uchenna Chima, and today I'll be solving Leetcode problem 13, Roman to integer. So for this question, it says that we're given, it says that Roman numerals are represented by 7 different symbols, these symbols with corresponding values, and they're written in a particular way. So when we chain two i's together, we get a 2. When we chain an x and I together, we get a 12. So x is 10, and 2 i's are 1. And to get a 27, we just chain it 2 x's, a v, and 2 i's. So 2 10s, a 5, and 2 1s. That's 27. And it says here Roman numerals are written largest to smallest from left to the right. So largest to smallest. And there's some rules here that it says. It says 4 isn't written with 4 i's. Instead, the 4 is written as an I and v, because 1 is before the 5, and we subtract the 5 from it to make a 4. And the same principle applies to the number 9, which is written as ix, and there are 6 instances where subtraction is used. So 6 instances where we don't follow the conventional method of writing our numerals from largest to smallest. So in this example here, we have I and v, and I and x. You could also have x and l, x and c, c and d, c and m. So it's important to note that I is smaller than v, smaller than x is smaller than l, smaller than c is smaller than d, also smaller than m. So those are the rules that were told for this question, and the goal here is to just convert an input or a Roman a string represented as Roman numerals into a pure integer value. So here we're given 3 i's, we return 3. Here we're given this chain of characters, we return 58. So how do we do this? We know that there are 7 different symbols in the Roman numerals dialect, and they all have values, right? So why don't we first start off by creating a hash map to represent these different symbol value key value pairs, and we can just do a simple iteration through our input string and do the simple addition, where in the case that we're using the conventional way as how Roman numerals are written, largest to smallest from left to right, we just add the values together. But we can have some check here that checks if we fall out of conventional order, meaning that at some point in time we have a character that's actually smaller than a subsequent character. So in this case, if we were to encounter so this said here IXC. So in this case, if we were to encounter this x and c, we can say that this can be like a 90, right? We'd add like a 90 instead of a 10 and a 100 to make 110. So we subtract those values from each other, and that will just basically be how we go about solving this. So let's start coding it. So to begin, let's create our hash map. So we could call this Roman map equals a simple hash map, where we have 7 different symbols. I equals 1, v mass 5. Let's copy and paste a few times. Alright, then we have x equals 10, L equals 50, d equals 100. D equals 500. Then we have m, which maps to 1000. Then, as I said, we need a result value to store our result, and we just simply go through our entire input. So how do we do this? We want to have, or we want to use a while loop, right? Because it just gives us greater control as to how we process our input. Reason being that we'll be processing our input sequentially, character by character. But as we're processing it character by character, we're also going to be checking each subsequent character to see if one of these special instances occur. That way, if they do occur, we know that rather than going character by character, we'd actually process two characters at once. So let's go ahead and do this. So I'm going to say pointer. So we're going to use like one single pointer for this, starting at the first index. So while our pointer is less than len for our string, what do we want to do? So we're going to say if s pointer and s, or rather if pointer plus 1 is less than len s, right? So if we're not if we're looking at the subsequent character and we're not out of bounds in the subsequent character, and the current character that we're on is less than the subsequent character, so as a pointer is less than, so let me put this in brackets to increase separation of constraints. As a pointer is less than s at pointer plus 1, then we want to process this. So to our results, we're going to add the subtraction of this, right? So to do that, we can just either take the absolute value like this, or we can do something like this to make it more readable. So we subtract the greater value from the small value, and we add that to results. We move our pointer by 2 places because we process 2 characters at once. Else, we want to process 1 character, so to our results, we just add the current character that we're on, and we increment our pointer by 1. At the end of this, we can just return our results, and if I didn't do anything wrong, this should work. The plus equals s a pointer is saying that our type plus equals int string. Oh, not s a pointer. We have our Roman map, so that's my mistake. So Roman map, to change this as well. Roman map that, then also that, and also change this over here. Okay, so this should fix the issues here. Okay, so now this passes our test cases, and let's submit the code. And this works. So what I had done incorrectly to begin with was that I was just looking at the character that we were on. So I just had s pointer plus 1 and s pointer. I was looking at the current character that we're on in our string. When in reality, the reason that we created the hash map was so we can get the Roman numeral representation of the current character that we're on. So I did was just to get the Roman numeral integer value of the current character that we're on, which is why I went back and just changed that. And yeah, that solves this question. And to go for the time and complexity, to understand the time and space complexity of this question, we know that for our space complexity, we're going to be using a hash map, which means that it's going to be O of n. And for our time complexity, we're going to be iterating through all the characters in our input string using a pointer. And on every iteration, we're only doing an O of 1 operation.